Hi guys! As I stated in class, only one video today. We're still in the same section, which is solving equations with variables on both sides. Here is our first example. Now, I know this looks very similar to the problems that we were doing yesterday. We're actually going to follow the same steps that we did yesterday, but something weird is going to happen at the end. So, as always, I'm going to start by drawing my red line right down the center. We learned yesterday that if you see parentheses, the first thing you should do is distribute. Next, we should look for like terms, and this problem does not have any. After like terms, we're going to notice that we have a variable on each side of the equal sign. So I'm going to take one of them and I'm going to move it to the other side using the inverse operation. In this problem, I have positive 10, so I'm going to move it by subtracting 10, once on the left and once on the right. And here is where something really weird happens. A positive 10x and a negative 10x will cancel. And so I have 0 x's on my left-hand side. But that also happens on my right-hand side. I have a positive 10x and a negative 10x, and those also cancel. And so all my letter x's are gone. They've all canceled out, and I'm left with just numbers. Well, I'm supposed to be solving for x, and I don't even have a letter x anymore. And so if all of your variables cancel out and there are no more letters in the problem, this is a special case, and it gets a special answer. Before you can decide what the answer is, you have to look at the numbers that you have left, and you have to ask yourself, is this true or false? Does 12 equal 12? And the answer is yes, 12 does equal 12. This is a true statement. When all of your variables cancel out and you're left with a true statement, then you're going to write the special answer, infinitely many. There are infinitely many answers to this question. In fact, any number that you can think of will work in this problem. You can pick any number out of thin air. You can plug it into your x's and it will work. It will give you a true statement. You can check any number out there, all of them work. Okay, so this problem has infinitely many answers, and that's what you would write on your answer line, infinitely many. Let's take a look at another one of these. Again, just like we've been doing, I'm going to write that red line right down the center. Now, I'm going to go through my 5 steps. There are no parentheses in this problem, so I will not be distributing. But I do have 3 terms on the right-hand side, so at least 2 of them are like terms. So I am going to combine together my negative 3m and my 12m, and I'm combining them exactly the way that they look. So negative 3 plus 12 is 9. Next, I'm going to notice that I have m's on both sides of my equal sign. Now, I'm not just going to combine them together like I did with the negative 3 and the 12. Since they're on opposite sides of that red line, I'm going to move them. So I'm going to minus the 9m. And the same thing happens that happened on the previous problem. I've got 9 minus 9 is 0 m's, and 9 minus 9 is 0 m's. And so I have no more variables. I only have numbers. And this is also a special case. Now on this problem, this is a different special case because negative 4, that does not equal 5. This is a false statement. When all of the variables cancel out and you are left with 2 numbers that are not equal to each other, then your final answer that you would write on your answer line or choose on your Delta Math is no solution. This problem has no answers, not a single number. You pick any number you want, it's not going to work. 1, 0, negative 5,000, none of the numbers work. There are no solutions to this answer. For our final example, I just want to make sure that we are clear about when it is a special case. So let's try one more together. In this problem, I'm going to draw my red line. I have no parentheses, so there's no distributing. On my right side, I have no like terms, and on my left side, I have no like terms. So I'm going to go straight to that third step of moving my variables onto the same side. If I have to choose between a 2 and a 3, I'm going to move my 2. So I'm going to subtract 2x from each side. Next, to get my letter x by itself, I'm going to subtract a 5 from both sides of the equation. Now, here's where some students struggle a little bit. So I wanted to make sure that you understand that in this problem, the numbers are canceling out, but my letter x is not canceling out. Since there will still be a letter x in this question, this problem has an answer. I need to keep going. The letter x is still there. It's going to be on the right-hand side. And then we do have to put something on the left-hand side, so just 5 minus 5, it's 0. So you would write the number 0. All right, so if all of the numbers cancel out, that's fine. That's totally allowed to happen. And then your answer is just going to be the number 0. So this problem has one and only one answer, and that answer is 0. So again, sometimes we have a special case if all the letters go away, but if they still have a letter X in there, then it's not a special case and you need to write an actual number answer. This concludes our only video for the weekend.